Hello everyone, welcome. This is Shreyas here, your master teacher for physics at Vedantu, and this is our channel We Enthuse. And what an amazing start we had yesterday. So welcome aboard, and today is the first session of physics of flash drills. So what is flash drills? Flash drills is assignment series. So whenever we cover a substantial portion in our regular sessions on YouTube, we are going to post, an assignment for all of you to solve at home. And you guys, I know, are going to make a very sincere effort to solve all these questions. And the next day, we are going to discuss all the answers. Yes, and I'm going to discuss everything out here, just like all the other teachers are going to do. Because it's not just about giving you those assignments and just mailing you or providing you the solutions in a written form. No, we are going to discuss it out here so that you have very good conceptual clarity. And we all know physics is all about concepts out here. Okay, so do not worry guys, we're going to start the discussion session right away. And those of you who are probably very new to the session, please go ahead and download those PDFs. Those PDF links are there in the description box. There is one more way though, where you can get those PDFs, and that is via the Telegram channel. So you can find the Telegram channel link in the description box again. Go ahead, join in the Telegram group, and in the Telegram group, we'll not just be giving you these PDFs, we are also going to give you regular updates of whatever things are going to come. Okay, so do not worry, just go ahead, install the Telegram app, join the Telegram group. The link has been posted in the description box. Okay, so let's begin then. Now, okay, so this was the first question. We had to select which option is correct. Let's discuss this one by one. Now, before we start the discussion, let me tell you, vector has both magnitude as well as direction. Now, speed is a scalar and velocity is a vector. We all know that. Okay, in case you do not remember it, I am just reminding you about it. Okay, so just imagine there is a body which has constant velocity. Okay, if it has constant velocity, what does it mean? Its magnitude is constant as well as direction is constant. And what is the magnitude of velocity called, guys? It is called as speed. So if a body is going with constant velocity, its speed also is going to be constant. Yes. So the body has constant velocity, then its speed has to be constant. There is no doubt about it that its speed will be constant. Okay? So this says it is going to have varying speed. No, I don't think so. It is not going to have varying speed. So this option, one second guys. Yes. So this option obviously is wrong. Okay? So option A is wrong. Okay, let's go to option B. A body having constant speed can have varying velocity. Let me tell you a very funny story. Just imagine guys, you are sitting in a car. Okay, you are going on a nice vacation, and maybe somebody is driving, maybe your friend, maybe your relative, maybe your cousin, doesn't matter. And you enter a nice ghat section, windy road. Just visualize that. I know some of you have not even traveled for a long time because of all the coronavirus things happening out here. So just imagine you're going on a very beautiful vacation with your close ones, and somebody is driving, and they are driving at a very nice constant speed of, let's say, 50 kilometers per hour. Okay? And it's a ghat section, so it's a windy road. Now, since it's a windy road, you have to obviously change the direction, or else obviously you'll fall off the hill. Now just imagine if somebody asks you, are you accelerating? Then what will your answer be? If you said ki I'm not accelerating, then you guys are wrong. Try telling this to the person driving the car. Probably he is going to be very mad at you, because that poor guy is driving at a constant speed of 50 kilometers per hour, and if you blame him that he is accelerating, he is going to be really mad at you. Probably because he does not know vectors. Think about it. See guys, even if the car speed is constant, but since you are going on that windy road, your direction is changing, and the moment direction changes, what happens? It's a vector quantity guys, velocity. The vector quantity will change. Yes, that's right. So the vector quantity will change the moment the direction changes. So hence, even if you are going at constant speed, you can have varying velocity because the direction can change. And velocity is magnitude plus direction both. Hence, option B is correct. Even option C is correct. Think about it. A body having constant speed can have acceleration. Yes, it can have acceleration because direction is changing. And let me remind you the definition of acceleration. What was it? Acceleration was never rate of change of speed. It was always rate of change of velocity. Yes, rate of change of velocity, guys, not speed. So the moment velocity changes, understand there has to be acceleration, even if, I'm telling you, even if it has a constant speed. Please understand that. The best example which you will learn later on, and some of you might already know it, is uniform circular motion. A particle going in uniform circular motion goes with constant speed, yet it accelerates. If you know that example, I hope this option should be very easy for you to solve. Okay? So option B and option C both are correct. What about option D? If velocity and acceleration are in the same direction, then distance is equal to displacement. Come on. I'm going to make you guys the judge and you will only give the answer. Think about it. I'm going to travel from here to here in one direction. Okay. So this is the direction of my velocity and this is also going to be the direction of my acceleration. My velocity and my acceleration in the same direction. My displacement and my distance both will be same. What was displacement, my dear students? Come on, what was displacement? You join the initial point and the final position. That straight line, that ray which points from initial to final position, that straight line gives you the displacement. But distance, my dear students, was the length of the path which you take. So think about it. In this situation, when my velocity and my acceleration were in the same direction, my distance and my displacement both were same. Correct? Now just imagine my velocity is here, but my acceleration is behind. The moment acceleration is behind, that means I am retarding. Yes, I am slowly reducing my speed and I'm accelerating there. So when I go here, my speed should reduce, I should stop, and again I should go back. So think about it. My distance traveled is more, but my displacement is quite less. In fact, they are not equal. Just like when you throw a ball up, what happens? The speed gradually decreases because velocity is up, acceleration is down. Think about it. This situation is exactly similar to that. My velocity is here, acceleration is there. So I'm slowly going to retard, stop and come back. So my distance is more, but my displacement is hardly anything. So when velocity and acceleration are opposite, understand the displacement and distances won't be equal. But when velocity and acceleration are in the same direction, then I'm traveling in a straight line path without changing any directions. In that case, my distance and displacement both have to be equal. So hence guys, option D has to be correct. I hope this is making sense to all of you. Okay? See guys, it's not about the simplicity of the problem, but it's all about how much we can explore around that problem. Because I can very easily discuss this problem within 30 seconds or 1 minute also. But I don't want to do that because I've made a promise. I'm going to make you guys understand every bit of it. So do not think or do not worry about the time being consumed. We are going to discuss every bit in detail. Okay? Chalo guys, let's go to the next question then. Just 1 second. Okay, this is also a very good question. Now, in this question, understand the body is going, right? The body is going in an, it starts from rest, it accelerates uniformly, and that means it's not going to cover equal displacements in equal time. Just visualize a body, guys, moving with constant velocity. So when it is going with constant velocity, it will cover equal displacements in equal time intervals, right? But imagine a body which is accelerating. What will happen? Initially, it will hardly travel anything, but in the next instant, it will travel more. In the next instant, it will travel even more. So if you thought the answer for this question, the displacements which are done in successive intervals of time t, the interval of time is same. If you thought it is 1:1:1, that is wrong. Okay? That is wrong. So let's see what the diagram for this question will look like. I'm going to start from rest. So I'm going to start from rest over here. This is at t is equal to 0. After some time interval, let's say t, I'm going to reach over here. And this is going to be my displacement S1. Okay. Next, after some more time t, I'm going to travel even more distance. So this say is let's assume this time as 2t, because t plus t will become 2t. Okay. And this displacement in that interval of time is S2. Please understand, S1 is only this much and S2 is only this much. S2 is not this whole thing out here. Yes, please understand that. Okay. And in the next time interval, well, I reach over here. The total time is 3t, and this is basically what do you call S3. Okay, so this is my displacement S3. Now, what do we do to find the ratio of S1, S2, S3? Well, there are multiple ways. I think one way can be by using kinematic equations. So let's use kinematic equations and see what do we get. Okay, so for this part, if I use kinematic equations, which kinematic equation will you use? Yes guys, S is ut plus half at square, because it's all about time and displacements and acceleration. Oh, what about the acceleration? Well, just assume it to be a, some value a, do not worry, we just have to find the ratio, right? It will, I think it will get cancelled. So don't worry about what is this a, what is the value of it. It's going to get cancelled eventually. So what is this S1? Okay, so this S1, guys, come on, think. It will be u is 0 starting from rest plus half into, what is the acceleration? A, we just assumed it. And what is the time? It is just t. So t square. Okay, so therefore S1 is equal to half a t square. Great. Chalo, bahut hi badhiya. Now let's go to this whole displacement. Okay, this whole displacement we can go to, or if you want we can find the velocity here and then go about it, but I feel that that will be a little bit lengthy process. So what is S1 plus S2 going to be? Matlab starting from here till here. Okay, what is my initial velocity? Well, it is 0, right? Initial velocity is 0 plus half into acceleration into time, total time, guys. In covering this distance, what is the total time? Just look at this. It is 2t. So it will be nothing but 2t whole square. Okay. So what is S1 plus S2 going to be? Think about it. 2t square. Come on, guys. It is 4t square. So 4t square by 2. Okay. Which is going to be nothing but 2t square. But that a is also there. So 2at square. So that is nothing but S1 plus S2. But wait a minute. I just found out the value of S1. If I put it over here, I can obviously find S2 as well. So I'll put the value of S1 over here and I'll get it as half a t square, correct? Plus S2 is equal to 2a t square. Great. Now rearrange the equations and let's see what do we get. S2 will be equal to 2at square. When you shift this guy out here, 2 minus half is 1.5, which is nothing but 3 by 2. So this will become 3 by 2 at square. Well, great. What a big achievement we had. Now, let's find the total displacement. S1 plus S2 plus S3. Come on, let's find this out. So S1 plus S2 plus S3 is equal to initial velocity 0, correct? Which equation am I using? S is ut plus half at square. What is u? 0. I'm finding the total displacement. So plus half. What is the acceleration? I just assumed it to be a. Time, be careful, total time. It is 3t. So 3t whole square, guys. Great. Oh, but wait a minute. I already know the value of S1 plus S2. Yes. Come on, where is the value of S1 plus S2? Look over here. It is 2at square, guys. So why not put it over here? So it is just going to be 2a, correct, t square plus S3 is going to be, what is 3t whole square? Come on, it will be 9t square. 9 by 2, at square. So 9 by 2, at square. Take this guy over here. So what will S3 be? So S3 is going to be 9 by 2 minus 2 times of at square. Come on, think, do your math. It is 4.5 minus 2. how much it is? Come on guys, it is 5 by 2 or 2.5 times of AT square. That's my answer. Now I think I have found out the answer. S1, S2, S3 are in the ratio of 1:3:5. Did you see that? 1:3:5, because rest other things out there are the same. Half AT square, half AT square, half AT square is there everywhere. So that's how you get this. Now I know this solution is very lengthy. I didn't like it. Let's do it a little bit in a quicker way. Okay? So do not worry. You can always take a screenshot of this solution. Okay? So let's go and do this problem in a very different way and see how efficiently we can get this. Okay, I'm going to do this again. Let's do this again, guys. Come on. I hope your Josh is still high. So what I'm going to do is I'm going to make use of the fact that the area under velocity versus time graph, yes, what is the area under velocity time graph? Displacement. So let's use that. So there we go. Okay, I need my pointer. Here you come. Okay, so let's draw the graph. What is the particle doing? Oh, the particle is starting from rest. Okay, so whose graph am I drawing? I'm drawing velocity versus time. So this is velocity, this is time, 0. It has to start from 0 because it's starting from rest. The velocity should start from 0. It's accelerating uniformly. If it's accelerating uniformly, how will this graph look like? Will it look like this? Obviously not. If it looks flat, then the velocity is constant, guys. So obviously the velocity is not constant. Understand that. Okay, so it has to accelerate uniformly. That means it has to be a straight line. It can't be even a curved line. If it's a curved line, obviously it will be non-uniform acceleration, but here it has to accelerate uniformly. So straight line like this. Now what does it say? Take equal intervals of time. Okay, let's do that. I'm going to take equal intervals of time. Great. So this much is t, this much is also t, and this much is also t. Now guys, use your brains. Come on, use your brains. And oops, it's going to be a little bit tough. Okay, I cannot choose those colors out there. Anyways, forget it. So the area under velocity time gives you displacement. So what will this area give you, guys? What will this area give you? This area will give you displacement in the first t seconds. So that is S1. So this area is going to give you this first quantity S1 over here. Now think about it. The area under this graph is going to give you S2, the displacement done in the next t seconds. Now if you think carefully, this area is made up of these three geometrical figures, and each of this triangle is congruent to this triangle. Can you see that? Just observe. This geometrical figure is made up of one square and one triangle, and this square is made up of two more triangles. So what does it mean? The area of this thing, S2, what will it be? 3 times S1, because each triangle over here corresponds to this displacement S1. Okay, now what about this diagram out here? You can break it up into smaller parts. Count the number of triangles. You can clearly see there are 5 triangles, guys. So each triangle has an area S1. So S1, 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 S1. So S3 will be nothing but 5S1. So what is the ratio of the displacements? Come on. 1:3:5. If there was one more thing, it will be 7. One more thing, it will be 9. That's how simple it is. Isn't this solution very easy? Did you like this solution? Come on, go hit the like button then. Okay? Chalo, बहुत ही बढ़िया solution था. We have enjoyed this solution. Amazing solution this is. Great. Let's go to the next question. We have used the concept of area under velocity time is displacement. So let's go ahead. Let's go to the next question, question 3. Okay, this is a graph based question. What does it say? At what point approximately do you think is the average velocity of the particle 0? Okay, the average velocity of the particle is 0. Now think, what is average velocity, guys? Let's go back to the definition. Okay, just one second. Yeah, so the average velocity is always displacement divided by the time which you take. Okay, this was the formula for average velocity. Now, What was displacement? Remember, it was the straight line joining initial and final point. Okay, great. Now look at this graph. This is position versus time. It tells me where the particle is at what time. You tell me the time, I'll tell you where the particle is. Example, okay, where is the particle at 3 seconds? Okay, quickly look, 3 seconds. Okay, there it is. It is at 4 meters on the number line. So if you visualize a number line where 0, 1, 2, 3, 4, 5 meters are marked. So at 3 seconds, it is at 4 meters. If I ask you, where is the particle initially? That's it. Initial means time is 0 seconds. Okay, there it is. It is at 3 meters. If I ask you, when is the particle at 2 meters? When is the particle at x is equal to 2 meters? Look at that. X is equal to 2 is somewhere here. So somewhere between 0 and 1, it is at 2 meters. Again, it comes to that same point between 1 and 2 seconds. And again, it comes to that same point at 5 seconds. So I don't know, this particle is somewhat crazy. It's going and coming back to the same point. That is what this graph tells us. Okay, so now that you got some feeling of this graph, let's solve this question. So when is the average velocity 0? So think guys, over here, the particle started at 3 meters. So if I imagine the number line 0, 1, 2, 3, the particle started from 3 meters, it went to 0 and again came back to 3. Oh, look at that. Look at that. The particle has come back over here. When did it come back? It came back at 2 seconds. Yes, it came back at 2 seconds. So 2 seconds has to be one of the answer. Think about it. Because the initial and the final positions are the same. But that's not all. There is one more point. Yes. Look at that. The graph goes up and comes back here. At 4 seconds also, the particle comes back to its original coordinate. So this 4 seconds has to be the second answer. Yes, so there are 2 answers to this question. It's very easy to miss the second answer. These kind of questions can come in JEE Advanced, where you have been asked, in multiple choice, at what times do you think the average velocity is 0? So this is one type of question like that. Okay, so we use the definition of average velocity and we saw on the graph when all does the particle come back to the same point. I hope this is clear. Okay, so are you ready for the next question? Chalo, let's go to the next question then. Just one second. Okay, so the next question is, the graph is the same, but the things which are asked are slightly different. So what is asked? What is the distance and the displacement from the start? Okay, from start till 5 seconds. Okay, 5 seconds is here. So you just have to concentrate on 5 seconds, guys. Okay, so just concentrate only on 5 seconds, nothing else. Okay, okay. And from the start, that means from 0 seconds. So at 5 seconds, where am I? Think about it. At 5 seconds, I am at x is equal to 2 meters. Great. So I'll box this off. Where was I initially? Initially means time is 0. That means I was at 3 meters. So now just think about the number line. Initially, I was at 3 meters. Eventually, after 5 seconds, I have come to 2 meters. Displacement doesn't worry about the path. It's just a straight line joining the initial position to the final position. So what is my displacement? X is equal to 3 to x is equal to 2. I think it is backwards, guys. Yes, the displacement is backwards. So it would be negative. So displacement, guys, is going to be -1 meters. Understand that. From 3 to 2. I have come backwards. So that's why displacement is -1. And if I have been asked what is the average velocity. Okay, so if I have been asked what is the average velocity, then what is average velocity? Displacement divided by time. What is the displacement? -1. What is the time? 5 seconds. So -1 by 5, do not forget the units, of course, meters per second. So that is the answer for displacement and average velocity till 5 seconds. Okay? I hope this is clear. Now I've done the easier part first. Most of you would have failed at the second part. What is the distance and what is the average speed? Because obviously if you get the distance, you are going to get the average speed. So let's visualize this. I'm going to animate myself as this graph moves. Okay, so let's try this out. So initially I'm at x is equal to 3. Okay, so just visualize a number line. Towards this side is positive, this side is negative. Somewhere here is the origin. I'm standing at x is equal to 3. What do? Okay, I go back to origin. How many meters did I travel? Think about it. How many meters did I travel? 3 to 0. I traveled 3 meters. So to find distance, you have to add all the path lengths basically. So I have traveled 3 meters. Okay, so keep this in mind. Then after 1 second, what did I do? Okay, I moved ahead. And at 3 seconds, I'm at 4 meters. So how many meters did I move, guys? Come on, count it. It is 4. So 3 plus 4. Okay, keep this in mind. Now, I didn't stop there. After reaching to 4 meters, what did I do? From this part to this part, from 3 seconds to 5 seconds, I have gone behind. And I have gone to 2 meters, guys. So if I have gone to 2 meters, so from 4 to 2, how much more did I travel, guys? I traveled more 2 meters. So 3 plus 4, 7, 7 plus 2, 9. So I have traveled 9 meters, and that, my dear friends, my dear students, that is the answer. 9 meters. Yes, you have to consider the fact that I am changing my direction. So whichever point I change my direction, at that point, or rather I would say till that point, you calculate the individual distances. So if I'm going from here to here, okay, calculate that distance. Then I'm going from here to here, calculate that distance. I'm going again here, calculate that distance. Add all this up, that will give you the distance. Remember, the odometer which is there in your vehicles, in your car, in your bikes, whatever, that always gives you distance. Matlab means that whenever you go or whenever you travel, that odometer's number always increases. It never decreases. Just because you went to some place and came back, that odometer does not decrement itself. You will not see the value decreasing, right? Whenever you go and come back, your displacement might be 0, but the odometer's value always keeps increasing. Odometer is that device which tells you how many kilometers you have traveled in your vehicle. Okay? So keep that in mind. Odometer gives you distance. So same thing. I have traveled back and forth multiple times. So for each section, I have found out individual distances and added them. Now, obviously, last part is very simple. What is the average speed? So guys, average speed. Come on. Now this is very easy. It is 9 divided by total time, which is 9 by 5 meters per second. That's the answer for this question. Okay. I hope now it's clear. Let's go to the last question. I know you guys are waiting for it. So let's go for it. Okay. Oh my God. I think my mistake. I went to the answer. Okay. Let's go here. Okay. So you would have often heard that some people are very good in reacting. They have very good reflexes. So what is a reflex? Reflex tells you how quickly you react to something when a panic situation arrives. So just imagine you are driving a car. Maybe many of you might not be having that license to drive a car right now. But let's say you're driving a bike or a scooty or something like that, and suddenly you see something. You are obviously going to take some time to react. In this case, our lazy driver out here takes how many seconds? Oh my God, he takes 1 second, guys. He takes 1 second to react. Okay, fine, no problem. And after 1 second, he starts braking, and let's say he applies maximum brakes and he retards at a rate of 5 meters per second square. And after some time, obviously, he's going to stop. So the question is, what is that braking distance, that minimum braking distance that you will get? Obviously, if he reacts little bit later or if he retards little bit slower, his braking distance will be quite large. Let's play it safe. He's going to react very quickly and he's also going to apply maximum brakes. So let's see, what do we do? What do we do? Okay, I feel that first let's calculate how much does he move in the 1 second time he takes to react. Okay, but before that, let's convert this kilometers per hour. I don't like this. It's kilometers per hour. Let's convert this into, okay, my bad. 1 second. Oops. Okay, my bad, guys. Let's convert this into meters per second. So 72 kilometers per hour is how many meters per second? Bolo, come on. 72 kilometers per hour is how many meters per second? What is the factor that you will use, my dear students? Yes, 5 by 18. So multiply by 5 by 18, you will get it in meters per second. So this is going to be 20 meters per second. Okay, so this is 20 meters per second. So while moving with constant speed, that means he has not yet reacted. So duration, so the duration is basically 1 second. How much does he move? So that displacement S1, how much will it be? Velocity, which is 20 into 1, obviously it is 20 meters. Great. I hope everybody is understanding till here. He has not yet braked. He is about to press the brakes for that 1 second. That's his reflex time. Okay, now the next part. So while he brakes, okay, and I will say till he stops. So when he stops, what is his final velocity? 0. Okay, so V final is going to be 0. So which equation do I use to find the displacement during that time? Come on, I know the final velocity, I know the initial velocity, I also know the acceleration. What will you use? Obviously the third equation of kinematics, which is V square is U square plus 2as. Let's use that very quickly. Final velocity is 0, so V square is equal to initial velocity. Where is it? Where is it? Yes, 20 meters per second. So 20 square plus 2 into acceleration. Well, his retarding, that means the retardation, I should put it as -5, be careful about it, into the displacement S2. So let's shift these numbers over here. 2 5s are 10 and I'll put it over here, so that will become 10 S2. And what is 20 square? 20 square is 400. So I'll put 400 over here. So what is S2, guys? It is going to be 40 meters. That's right. So what is the total braking distance? 20 plus 40. So total obviously is going to be 40 plus 20, which is going to be, where is it? Yes, 60 meters. 60 meters, quite a number, I must say. That's the total distance, road distance he's going to take for him to stop completely. If his reaction time was better, if his brakes were good, if his speed was less, obviously this number would be smaller. That's how it is. Okay, so I hope you have understood the solution for this problem. And that's all, folks, for today. I hope you have enjoyed this series. Guys, I have kept it really slow. So if some of you felt that I was slow, please keep in mind that there are all kinds of students from all parts of the country. There are some students who do not even have access to proper education, right? So I need to make sure that everybody understands. So if you ever felt that I'm a little bit slow, that's because I want everybody to understand. You can obviously play it at a little bit faster speed to understand it a little bit faster. Okay, so that's what you can do. So what are we doing tonight? We are going to continue 1D kinematics and we are going to discuss free fall motion. Yes, there are very interesting problems that I am going to take up tonight. So do not forget to attend that class. See you guys. Have a great time. Stay safe and stay at home. Bye bye. Signing off. Take care.